I think we could start. It's about that time. Hello, happy, almost said Wednesday. It's Thursday. Happy Thursday. End of the week. Do you have any questions for me before we start? Today, the plan is to finish up the last tiny little bit of lesson 14, and then we're going to go to lesson 15. Just make absolutely sure I've got that in here. Yep, I do. I do have it. Just heads up on what we're going to cover today from lesson 14 is not in the quiz for 14. I mean, you could use the material in theory, but it isn't directly on that quiz. So you should have been able to complete the quiz prior to today's lesson. But if you read it, I totally understand. Okay. Well, let's go ahead and start then with that last little bit from lesson 16. We're continuing with graphs of lines. So we have jumped into the last third of our class, which is a lot of it is about graphing and linear equations. We'll do a little bit aside from that, but we'll bring graphs into a lot of what we're doing. So this is an intro to graphs, graphs of lines. We talked last time about how to determine the slope of a line, how to determine the y-intercept, and then we ended with this explanation of this particular form of the equation of a line. It's called the slope-intercept form. We did a little bit of work with solving equations for the y variable. So we're working with equations in 2 variables now, rather than just one. And if you happen to have an equation in 2 variables, x and y, and you write it in such a way that y is by itself on one side of the equation, everything else is on the opposite side, then that automatically tells you the slope of the linear equation, if it is a linear equation, and where that line crosses the y-axis. Saw a few examples of that. Let's do a few more. So I'll do a couple of these. I'll let you do one. I'll do the first one and the last one. So the first one, if I want to identify the slope and the y-intercept of an equation in 2 variables. So we have our y, it is by itself on one side. We have our x on the opposite side. This is certainly an equation in 2 variables. This looks like the y equals mx plus b form. If this is the case, then the slope, m, will be the coefficient of the x. It doesn't include the x itself. It's just that number. It's being multiplied by the x. So it's -4/9. And then b, that y-intercept, will be the constant. So b is 4, +4 in this case. So we technically could include the sign before it, because if there were a negative sign before it, then my b would be -4. Okay, so there's that one. Let's look at number 3. I'll let you do number 2. I'm again going to use this y is equal to mx plus b form to do a comparison. I'm going to determine what is the slope and what is the y-intercept. The below equation is certainly solved for y, but I have to be careful. If I want to determine what the slope m is, then I can note that in my slope-intercept form of the equation of a line, m is being multiplied by x. So I am looking at the below equation and trying to figure out, well, what is the number that's being multiplied by x? What's the coefficient of x? And in this case, that's -3. So here, M, the slope is -3. Similarly, B, I want to find B in this equation. It is the number that is constant, so it's not multiplied by X. So in this case, that is 5. So my slope is -3 and my B is 5 for this equation. Okay. All right, why don't you do this one? Put the slope and the y-intercept in the chat, please. Okay. Couple minutes for this. And we'll finish up with one more concept. Great. For another minute or so, chime in. So for 2, if I am looking for the slope and the y-intercept, I'm going to note that if y is by itself on one side of the equation, I can look at the other side in an equation in 2 variables and note that the number that's being multiplied by x is the slope. So my slope is 1/3 in this case. And then the constant term is my y-intercept. So I agree that the slope for this equation is 1/3 and that the y-intercept is -4. Any questions on that one? Good. Let's talk about how to connect this to a graph. So we've talked about what the y-intercept is graphically. We've talked about what the slope represents graphically. We've talked about what they are in an equation. Let's put all that together. Okay. If I want to graph a linear equation in slope-intercept form, then I begin by graphing the y-intercept. So the y-intercept tells me one point on the line. This is that graph that or that line that you all were just telling me about. It has a y-intercept of 4. I'm going to take that y-intercept and I'm going to put it on my graph. So that y-intercept tells me that the line crosses the y-axis, which is this vertical axis, at y is equal to 4, or -4, excuse me. This is the y-axis. Then I'm going to go from the origin 1, 2, 3, 4 down. That is the y-intercept. Y-intercept. Okay, so that gives me 1 point on my line. Now that I have 1 point on my line, I can use the slope to find additional points on the line. So let's find maybe a couple of additional points for this line. Let's determine the slope first of all, in terms of rise over run. So you told me that the slope was 1/3. So 1/3 is equal to the rise over the run, or if you prefer to think of it as the change in y over the change in x, you may do that. Change in x, okay? And what that means is, from that point that we just put on the coordinate plane, the y-intercept, we're going to go up 1. So I'm going to rise 1, and then I'm going to go to the right 3. I'm going to run 3. That gets me to another point on my line. If I want a third point on my line, I could do the same thing. I could say, from that point that I just found, right here, I could rise 1, and I could go to the right 3. 1, 2, 3. That gives me a third point on my line. Once I have 2 or 3 points, I can connect the dots. And that gives me the graph of that equation. It's a very poor graph. Let me try that again. There we go. That goes to points a little better. Okay. Any questions on that so far? Okay. One other thing I should probably note here. We have seen how if you take a negative divided by a negative, you get a positive. Here I was able to go up 1 to the right 1, up 1 to the right 1, no problems. But if you prefer to know a few points instead of to the right of that y-intercept, if you prefer to know a few points over here instead, we could do that, because we could note that 1/3 is the same as -1 over -3. So we could interpret this as a rise of -1 over a run of -3. So on the right, what that would mean is I'm going to, from that y-intercept, I'm going to go down 1 and to the left 3. 1, 2, 3. So that gives me another point on my line. I could go down 1 and to the left 3. 1, 2, 3. And I didn't draw my line very well, but that point should be on the line. Sometimes, or often, we can use the positive form of that, but sometimes it's convenient to have another way to write it. And this, we might see that in the future, especially when we're dealing with negative slopes. Questions on that? Okay, let's do one more. Should you have graph paper? I am not going to require that you have graph paper. It will make your graphs more accurate, to have graph paper. So for the sake of tests and stuff like that, it's not a bad idea, but I'm not going to require that you have it. We'll talk a little bit more when we talk about the project of kind of what, like how to write linear graphs and stuff like that. But we're not getting super far into like the nitty gritty of graphs. So if you're confident in drawing fairly accurate coordinate planes using a ruler, stuff like that, I'm not going to require you have graph paper. Okay, good question. All right, let's see here. I'm trying to remember what I was planning on doing with this. These are kind of summaries of, is that what these are? There, okay. I'm gonna skip those next three because they kind of summarize this process of writing an equation in slope-intercept form and then graphing it. I mostly just want to work out a couple with you, but if you want to see that process worked out on the PDF, it is in those slides above. As I've mentioned, these were rearranged recently, and I did not perfectly rearrange them. I should have taken those out. So let's do this next one. Okay. This one we've actually worked with. This particular equation we have solved for y before, but just as a reminder, if I want to solve for y, then I'm going to subtract 4x from both sides. Gives me 6y is equal to, oh no, I take it back. We have not done this before, but we've done this process. So 6y is equal to negative 4x plus 12, okay? And now if I want to get y by itself, I want to divide the left-hand side by 6. And then since we have a sum on the right, I have to divide the right-hand side by 6 as well, both terms on the right. So that leaves me with y on the left is equal to negative 4/6. Graphically, we could use negative 4/6 if we want. Plus 12 divided by 6 is 2. It is often simpler to reduce the slope, however. So that negative 4/6, we could divide the top and the bottom of this fraction by 2 to reduce it as much as we can. So that leaves me with negative 2/3. I think that's what I'm going to write in my equation instead. Instead of negative 4/6, I'm going to use that negative 2/3 just because those are smaller numbers and easier to deal with. We will get the same graph though, regardless of which form of the slope we use. Okay, now that we have that, let's put this on the coordinate plane. So I have solved for y because this is now in slope-intercept form. Slope-intercept form. And what that means is I automatically know the slope and I know the y-intercept. If I know those two pieces of information, I can graph. I'm going to put my y-intercept on the graph first. This gives me a point. Intercept. That tells me that if this is my y-axis, my line will cross the y-axis at this point, y equals 2. I can start at the origin and go up 2. So we have that 1 point. Now I can use my slope to determine other points. So that slope negative 2/3, I can interpret that as the rise over the run. Rise over the run. The previous one did not have a negative sign. Whenever your slope is negative, one thing we talked about is we can expect the line to be going down, left to right. What that means algebraically is I can interpret this slope as having a negative sign either on top or on bottom, but not both. So I can say -2 over 3 or 2 over -3. If I put negative sign on both the top and the bottom, just like the previous one, I would end up with a positive slope, which I don't want. But I can choose to apply that negative sign to the top or to the bottom, and that will give me a negative result. I think I'm going to apply it to the top for now to find another point. So that means the rise is -2 and the run is 3. So from that y-intercept, I'm going to go down 2 and a rise 2. It's negative, so I'm going to go down instead of up. And then I'm going to run 3, +3, which means I'm going to go to the right 3. 1, 2, 3. And that leaves me at this point right here. So that gives me a second point on my line. If I chose the opposite option and put the negative on bottom, I would do a very similar process. So I am going to start at the y-intercept, and I'm going to, instead of rise -2, I'm going to rise +2. So I'm going to go up 2. And then -3 means I go to the left 3. 1, 2, 3. And we can note that both of these points lie on exactly the same line. They make the same line, or the first 2 points make the same line as the second 2 points. So either way that we choose that slope, we should get the same graph. And I can connect the points on that graph with a line. And there it is. There's the graph of my line. Questions on that? One more of those, and I know I'm taking a little bit with this. This is a foundational thing, not on your quiz, but we're going to use this concept quite a bit. So I think it's important that we get it. Let's go ahead and do this equation. We want to solve it for y, because we want to write this in y equals mx plus b form. If ever you want to know the slope and the y-intercept, a good goal is to write it in y equals mx plus b form. I'm going to, first of all, isolate that y term. So subtract 5x from both sides. That leaves me with 2y. My PDF will save. 2y is equal to -5x minus 4. Okay. And now I can get y by itself by dividing all terms by 2. Gets rid of that 2 multiplied by the y. That leaves me with y is equal to, I can't reduce the -5/2. I can't divide the top and the bottom by the same thing, but I can divide 4 by 2, and I get 2. Okay. That gives me the slope-intercept form of the equation of a line. If I want to use that to graph, I'm going to begin with the y-intercept. That tells me that the graph crosses the y-axis at y is equal to -2. So I'm going to start at the origin and go down 2 on the y-axis. Okay. Second, I want to use my slope to find another 1 or 2 points on my line. And I can note that that negative sign can be applied to the top or it can be applied to the bottom. So I can do -5 over 2 or 5 over -2. Either way, that's a representative of rise over run. So change in the up and down direction over change in the left-right direction. I'm going to start at the 1 point that I know is on the graph at the y-intercept. And let's say we use this first form. I'm going to go down 5. 1, 2, 3, 4, 5. And then I'm going to go to the right 2. 1, 2. There's 1 point on my line. I could use the other form of my slope and find another point, which means I would go up 5. 1, 2, 3, 4, 5. And then I would go to the left 2. 1, 2. Either way, we get the same line. So I'm going to connect the dots with a straight line. And as long as you can connect all 3 dots with a straight line, you probably figured out those points correctly. We okay with that? Okay. Great. Well, that finishes up lesson 14. We are going to jump into lesson 15. So let me jump over and grab that handout, that PowerPoint. I think it's down here. There it is. So we've talked about graphs. We've talked about how they can represent relationships between 2 variables. We've used that one equation, y equals mx plus b, and related that to a graph. This lesson, we're still working with linear equations, but instead of just being given an equation, we're going to be given some information about the line and asked to write our own equation. So that's kind of big picture what we're doing this lesson. So quick transition, sorry. We're going to generally be looking at 4 cases if we want to write the equation of a line. We want to be able to write the equation of a line if you are given those 2 specific values, the slope and the y-intercept. We want to be able to write the equation of the line if we are given the graph of a line. So this first case is probably the easiest because we have the slope-intercept form of the equation of a line. The next case is certainly doable. We've seen from a graph how we can find the slope and the y-intercept. The next couple of cases are a little bit more algebraic. We can write the equation of a line given the slope and a point that's maybe not the y-intercept. And then we can also find the equation of a line if we're given really any 2 points on a line, which kind of makes sense because, you know, if you put 2 points on the line on a graph, you can connect them and that's enough to determine a line. So we should be able to also make the equation of a line if we know any 2 points on it. That's where we're going this particular lesson. Okay. Let's start with that first case. And I'm not going to spend as much time on this one. It's kind of the easier case. If we want to write the equation of a line, say we're given the line's slope and we're given the y-intercept. Given the slope and given the y-intercept. Then you know your y equals mx plus b form of the equation of the line. That is one that you should have on a note card, put it on a sticky note, have that in your back pocket, ready to use at any given point in time. We'll use it a lot today. If you are directly given the slope, that's our m, and you are given the y-intercept, that's our b, we can just plug those into our equation. This becomes y is equal to 4/9. X stays as a variable x plus -7 or -7 if you prefer, because the sign goes before it. That's our equation. That's all we've got to do. Any questions on that? That's not too terrible if you're given the slope and the y-intercept. This is the graph. We just showed how you can graph a linear equation giving the slope and the y-intercept. This one has a y-intercept of -7, so it crosses the y-axis at -7. And it has a rise of 4 and a run of 9 when it comes to the slope. Okay. What if we're not told those two pieces of information? What if we are given a graph? Well, we know enough at this point to be able to determine what the slope and the y-intercept are if we're given the graph. We talked about that last time. We're going to, again, utilize that y equals mx plus b form. We can identify the slope of the line from the graph, plug that in for m, and then we can identify the y-intercept from the graph. Plug that in for b, just like we did with the previous one. Let's see a couple of examples of that. First thing I'm going to do is look for slope, or excuse me. Yeah, we could look for slope. Why not? You can actually do this in any order. It doesn't really matter. But since that's the way I wrote it here, let's look for slope. Let's look for m. That's probably the more difficult one. To look for slope, I'm going to find a couple of points on the line. Let's see. This is one point on the line. That's pretty obvious. That is the point 0, -5. So if I start from this point, the origin, I'm not going to go left or right any, but I am going to go down 5. So my y value is -5. It's an xy pair. Here is another point on my line. Doesn't really matter which 2 points you pick. I could have picked this one. I could have picked this one. So any 2 points, regardless of where they are, as long as they're on the line, should do. Let's just use this one. This is the point 3, -4. Go to the right 3 and down 4 to find that location. We can note that to get from one point to another, say point 1 to point 2, call it that, I have to go up 1. So my rise is 1. And then to the right, 3. So my run is 3. If I know my rise and I know my run, then I know my slope is the rise over the run, and that gives me 1/3. Okay? So that's one way of doing it. That's a graphical way. Another way is we could remember that we have another formula that we talked about last time. If you want to find the slope given 2 points, then it is y2 minus y1 over x2 minus x1. That works perfectly well to find the slope. Let's call point 1 x1 y1. Let's call point 2 x2 y2. And then I could note that m is equal to y2 is -4 minus y1 is -5 over x2 is 3 minus x1 is 0. -4 minus 5 becomes -4 plus 5. -4 plus 5 is 1. 3 minus 1 is 0. So exactly the same slope, regardless of whether you use the slope formula or you use the concept of rise over run. I don't care which you use. Do the one that makes the most sense to you. Okay, questions on that? All right, so we have the slope. If we have the y-intercept, that's enough for me to write my equation. The y-intercept, maybe clear up a little bit of this I've got. The y-intercept is the place where the graph crosses the y-axis. Place where the graph crosses the y-axis, we've actually already noted it is right here. The y-intercept. And we noted it as an XY pair, but for the case, or for the purposes of our equation, all I care about is that Y value. It's -5. So we have a slope of 1/3 and a y-intercept of -5. That lets me write my equation. Equation is y is equal to mx plus b. If I substitute 1/3 for m and I substitute -5 for b, we have our equation. Questions on that? All right. Well, how about I let you at least start one of those? I want to make sure that we get to the rest of this lesson, but why don't you attempt this one? So we've got a graph. Find the slope. Find m. Find the y-intercept. Find b. And then write the equation using those two. I'll zoom in a little bit on the graph so that you can see it a little bit better. Take maybe 3 minutes for that. Put your answers in the chat, please. And it's okay if you're not sure, but I want to at least allow you to begin it because sometimes that helps with figuring out how to do it. And if you want to just write your end resulting equation, that's totally fine. Has everything needed in there. Okay. Good. A minute or so. Good. All right. Looks like y'all are pretty darn good, especially on the y-intercept portion. This is where the graph crosses the y-axis. It's at +3. Therefore, my b is +3. In order to find the slope, I need at least a couple of points on this line. So here's one for sure. Crosses the y-axis there. It looks like this is another one. Down at 1, -1. So to use the slope, or excuse me, the rise over the run form of that, I can note that to get from one point to another, say from 0, 3 to 1, -1, I can go down 1, 2, 3, 4. So my run, or my rise, excuse me, is, since I went down, it's -4. And then my run, I'm going to go to the right 1. So my run is +1. Looking at my slope, it appears that it is going down from left to right. Therefore, I should have a negative slope. My rise over my run is -4/1, which you could just write as -4. Those two mean the same thing. So to put those in an equation, I'm going to get y is equal to m, which is -4. Multiply that by x, and then add 3. So that is the equation of my line. Any questions about that one? All right, great, sounds good. Well, let's talk about the next couple of options for finding the equation of a line. So let's talk about the ones that are a little more algebraic. Let's say that instead of being given a graph or being given the slope and the y-intercept, let's say we are given a point, any point, maybe just assume it's not the y-intercept, though it can be used to find that, and then we're given the slope. Well, we're halfway there if we're given the setup. We are at least given m. We're given a portion of our y equals mx plus b equation, which we are still going to utilize. You've been in other algebra classes and you use other forms of equations. We're not going to do that. We're just going to stick with this one. Once we have the slope, then we're given one point, and that point is an xy pair. We can substitute those values for x and y in that y equals mx plus b equation and use those to solve for b. Once we have b, we can bring back our y equals mx plus b equation and substitute. Let's see how this works. How many? I think I have two examples of this. Here we go. Let's say we're given the following. We are given that we want to write the equation of a line with a slope of 7/2, or excuse me, 2/7, and passing through an xy pair, a point, -4, 3. Okay, that is not the y-intercept. And in fact, if I zoom in a little bit on this graph, I don't know if I can actually tell what the y-intercept is exactly from that graph. Certainly the graph crosses the y-axis at this point, but I don't know exactly what that number is. It looks like it's a little bit bigger than 4, but I don't know how much bigger. So I don't think I would have been able from the graph to directly write this particular equation, at least to determine the y-intercept. So I've got to think about something different. First of all, I know half of my equation, okay? I know that if I have my equation y equals mx plus b, that is the big picture equation we're going to use. I know m. So let's go ahead and substitute that. Y is equal to 2/7 x plus b. Great, we got that far. That part's not hard. The more difficult part will be finding b. What we do know though is that -4 represents an x value and 3 represents a y value. I can substitute those into this equation now, and that will leave me with only one unknown, and we know a little bit about solving for a single unknown. I think we can handle that. So if I substitute 3 for y, still have the 2/7. And then, oh, this will be nasty. -4 for x. -4 for x. I still have my b sitting out there. We can solve for b. We can isolate b using solving processes from the test 2 material. I'm going to start by noting that I have multiplication here, parentheses. So I'm going to do that deal with the parentheses first. 3 is equal to, oh gosh, your calculator can handle this, but just to walk through it, I will go ahead and show how to do it because we've talked a bit about fractions. -4 is -4/1. To multiply two fractions, we multiply the tops. 2 times -4, and we get -8, and we multiply the bottoms. 7 times 1, and we get 7. We still have plus b. Okay. And now, if I want to solve for b, this is a simple equation. So I can undo my addition by adding 8/7 to both sides of the equation. Again, this is a little bit nasty. 3/1. I can rewrite with the denominator of 7. This becomes 21/7. I'm multiplying the top and the bottom of that by 7, plus 8/7. That is equal to 29/7, which is equal to b. So I have my m and I have my b. That's enough for me to be able to write my equation. Y is equal to m 2/7 x plus b, which is 29/7. So a little bit more work, a little bit more algebra, but using that slope-intercept form of the equation of a line, we can still do it. Questions about that one? And yes, occasionally you'll get nasty fractions. Use the fraction button on your calculator to handle those if you have trouble with that. Right. Let's do another one then. When I switched over the 8/7, so is it the addition of the 8/7 that that bothered you, or is it should be added? The fact that I added it to the 3.
Oh, I see. I see now.
You see it now? Okay,
Yeah.
great. Other questions about this one? All right, great. Well, let's do another one without fractions. See if we can work with that one. So same idea. We are working with this slope-intercept form of the equation of the line, y equals mx plus b. And we want to essentially find m and find b to write the equation. We are given, in this case, a slope. We are told that the slope of this particular line is -2, and we are told that the line passes through the point -3,5. If I'm given the slope, that's great. I'm automatically given m That's a part of my equation. So my equation becomes y is equal to m, which is -2x plus b. So we got half of it just by being given the slope. Our job is to now find b. And we do that using the fact that this is an xy pair. So I can substitute -3 for x and 5 for y in the equation. That'll leave me with an unknown of b, the y-intercept, that I can then solve for. So I'll do that here. Substitute 5 for y is equal to -2 times -3 for x. Then I still have that b that's being added. Okay, we only have one unknown there. We know how to solve it. I'm going to focus on parentheses first. I'm going to do this multiplication on the right-hand side. 5 is equal to -2 times a -3 gives me a +6. Calculator can handle that. Plus b. Okay. This is now a simple equation. So I'm going to deal with any addition first. That's on the variable side, which means I'm going to subtract the 6 from both sides of the equation. 5 minus 6 is a -1 is equal to b. So we have now found that remaining half that was needed for writing this equation. So now my equation becomes y is equal to m, which is still -2, times x minus 1. Note that I did not write 5 is equal to -2 times a -3 minus 1. While that is true, the idea of an equation is that I want to write a relationship between two variables. And here those variables are x and y. So in my final answer, I have to have an x and I have to have a y. This ordered pair shows me one pairing between those x and y values, but the equation itself represents every pairing. It represents a way to obtain a y if I'm given a particular x for any x value, not just that specific x value, -3. So don't forget as a last step to bring back your x and your y. Questions on that? One more form then for us to talk about, and we'll try to get to some practice at the end. It may or may not happen, but we will try. So we can find the equation of a line given the slope and 1 point. We can find it using a graph. We can find it using the slope and the y-intercept. We can also find the equation of a line if you're just given 2 points and you are not given the slope. If 2 points on a straight line are known, then the equation can be determined using that slope formula that we have talked about. M is equal to y2 minus y1 over x2 minus x1. Once we have the slope, well, we have at that point a slope and 2 points on a line, so we can go back to what we just did prior to this on that very last slide, and we can use the y equals mx plus b form to find the y-intercept. So this one requires one additional step to what we did above. So let's do an example or two of that. Let's write the equation of a line that goes through the two xy pairs, or excuse me, the two ordered pairs, 6, -3, and 4, 1. Last time we talked about how to use the slope formula to find the equation of a line, or to find the slope of a line. Let's just let this first point listed be x1, y1. Let's let the second one be x2, y2. You could switch it if you prefer, doesn't really matter. But if we use this form, then m will become y2, which is 1, minus x2, or excuse me, minus y1. Let me not do that to you. Minus y1, which is -3, over x2, which is 4, minus x1, which is 6. So we've set it up like that. And I can remember that in this form, I want to simplify on top and bottom before I do the division. Doing that here. 1 minus a -3, these two negatives become a positive. So that's 1 plus 3, which is 4, over 4 minus 6. Our calculator can handle that. We can note that we're taking a positive and subtracting something that's bigger. So we should get a negative number. 4 minus, or a -2, in fact. If I can divide top by bottom without getting a decimal, I will do that. 4 divided by -2 is -2. This becomes my slope. Questions on that part so far? Okay. So that was part 1. So I have that, I can put that into my equation. So my y equals mx plus b becomes y is equal to -2x plus b. So now I am halfway done. My next step is exactly like the previous problem. I'm going to choose one of those XY pairs that I'm given. It does not matter which one. And I'm going to substitute that XY pair for the X and the Y coordinates in this equation. So given Y is equal to -2x plus b. And I'm going to use 6, -3. I've already got it labeled as x1, y1, so I may as well put it in there. So my x is 6 and my y is -3. So I have -3 is equal to -2 times x is 6 plus b. Great. Let's multiply. We have -3 is equal to -2 times 6 is -12 plus b. And now I can note it's a simple equation, so I can undo any addition. I'm going to add 12 to the left because -12 plus 12 is 0. Add 12 to the right. So that gives me 3 plus a -12 is 9 is equal to b. So we have m and we have b. If we've got m and b, it's enough to write the equation. Y is equal to m, which is -2x plus b is 9. Any questions on that one? Zoom out a little bit. Okay, I'll do one more of those, and then I think we'll have time for you to do a little bit of practice with these. Same idea with this next one. We want to write the equation of the line that goes through 2 points, -2, 20, and -8, -35. And we are going to use that slope-intercept form of the equation of the line, y equals mx plus b. My goal is I want to find m and I want to find b. If I have those two pieces of information, then that is enough to write the equation. I'm given 2 points, And given 2 points, I know how to find m. M is equal to y2 minus y1 over x2 minus x1. So I can call either point x1, y1. Let's just let it be that first point listed. And so this is x2, y2. Plug those into the equation. Y2 is a negative 35 minus, remember there's a minus in our equation. I'm subtracting y value from y value. So minus y1, which also happens to be negative. So I've got a double negative situation here. Divide that by x2, which is a negative 8. There's the negative in my equation. And then my x1 also happens to be negative. Lots of negatives. Let's simplify the top and simplify the bottom. Double negative becomes a positive, both on top and on bottom. So negative 35 plus 20 is negative 15. Negative 15. And then negative 8 plus 2 is a negative 6. Couple things we can do with this fraction is note, first of all, I've got a negative on top and then a negative on bottom. So my end result will be positive. I'll go ahead and note that. 15 over 6. So that's helpful. Those negatives cancel each other out essentially. And I can reduce this. I'm looking for a number that you can divide the top and the bottom by. It looks like both are divisible by 3. That leaves me with 5 halves as my slope. Okay, so that is our slope. That means I can put that in my equation. Y is equal to m, 5 halves, times x plus b. So that's half of it. We all right so far with that? All right. Now that we have the slope in place, let's go ahead and find the y-intercept. Let's find b. There was m. I think I did it in red. Let's find b. To find b, I'm going to take that equation, y is equal to 5 halves x plus b, and I'm going to take either of my points above, it doesn't matter which, and I can substitute the x and the y for x and y in the equation. I'll just choose my first point out of convenience and because they're smaller values. So I'm going to substitute negative 2 for x and 20 for y, negative 20. So negative 20 goes on the left-hand side in place of y is equal to 5 halves times x. X is negative 2 plus b. So we have substituted. We can now solve. Negative 20 is equal to, you can do the 5 halves times a negative 2 in your calculator. You will find that it is equal to negative 5. So that's nice. The whole number. That won't always happen, but it does in this case. I can now undo the addition. Add 5 to both sides because negative 5 plus 5 is 0. So that leaves me with a negative 15. On the left-hand side is equal to b. And that is the second half of what I need to write my equation. To write my equation, I'm going to substitute 5/2 for M and -15 for B. Questions on that? Ready? Are you sure? Should it be plus a -15? Good question. So I can write it like that. I can say y is equal to 5/2 x plus a -15. But if we have a double sign like this, so we have two signs together, when you're adding a negative, that becomes a single subtraction. So it's a little bit cleaner to write it as -15 instead of plus a -15, but both are technically correct. I believe that Canvas will ask for a single sign. So you will need to simplify it like that. Okay, good question. Other questions about this? Okay. All right. So there are 4 problems below. I would like you to please work number 2 and number 4. Pick either one first, doesn't really matter. Take your pick. But let's get a little practice with this. Take about 5 minutes on this, and then I will pause and we can talk about at least one of them, just depending on what I'm seeing in the chat. Just double checked on the plus minus 15 and Canvas will require you to write it as a single sign. Just heads up. You go ahead and keep working on those. If you haven't had the chance to finish, it's okay. Thing we can note about this first one is the 0.06 is on the y-axis. It's right here. So this is technically the y-intercept. I have my m, I have b. So for number 2, you get the equation y is equal to 1/5 x plus 6. Which is what you're telling me. It's 2 down in case you want to work on them later. Let's go ahead and go through the last one. A couple minutes we have. We have 2 points. We want to use those 2 points to find a slope and a y-intercept. M is equal to 8 minus 12 divided by 2 minus -6 x y1, or excuse me, y2 minus y1 over x2 minus x1 leaves me with a -4 on top. 2 minus a -6 becomes 2 plus 6, so that is an 8, which reduces to -1/2. 4 over 8 is the same as -1/2. So I've got y is equal to, we'll update our slope, -1/2 x plus b. Once we've got that, I can take, well, let's not use that point. Let's take this point, doesn't matter. And substitute those two values. Y is 8, -1/2, x is 2, plus b. 1/2 of 2 is 1, so this is -1 is equal to 8 plus b. I am going to now isolate b by adding 1 to both sides. That gives me that B is equal to 9. Therefore, my equation becomes y is equal to negative 1/2 x plus 9, and we're done. So if you got there, awesome. If not, no worries. You've got time to work through this. And yeah, reaching out to tutoring, meeting with me on this, you can totally do. There's a lot of concepts we're throwing into one problem, particularly for that last type of problem. So no worries if this will take a little bit of time, if this takes a little bit of time to click. But let me know if you have questions. Seeing a chat, yes, we can totally go through number 2. I've got some time, but I don't want to hold you all if you need to go after this. So yes, I can stick around if you have particular questions.
Yeah, I don't get where you get y equals 8 on that number 4. I don't understand how where that even came from.
That came from, that one I can pretty quickly clarify. I used this point to 8.
Why do you choose that one? I mean, I don't.
It actually doesn't matter which point I choose. I
So
can,
you could have used the 12 instead.
yep, I could have. I actually chose that one, chose this particular one because both numbers are positive. And I just think positive numbers are easier to deal with, but I could have just as easily used the other one. So I called 2x and I called 8y. So there's that one. And then there's a request to go over 2. Yep, we can totally go over 2. Let me find myself some room here. There we go. So number 2, there's a couple different ways you could have done number 2. So we know that m is 1/5, and then we have this 1 xy pair 0, 6. I'm used to xy pairs, so when I see something with a 0, I'm thinking, well, that's either on the x-axis or the y-axis, because either I didn't have to go up or down, or I didn't have to go left or right. If it is a y-intercept, if it's on the y-axis, then that's half of my work. To get to this point on my coordinate plane, I don't have to go up or down any because my x coordinate comes first, or excuse me, I don't have to go left or right any because my x coordinate comes first, but I will go up 6. So 1, 2, 3, 4, 5, 6, about there. This is a point 0, 6. If I know a point on the line where it crosses the y-axis, that is automatically my y-intercept. So that means B is my y coordinate of that, which is 6. If I know m and I know b, then I can write the equation of the line. Y equals m, which is 1/5, x plus b, which is 6. So that's one way of doing number 2. It's not the only way of doing number 2. If you didn't happen to notice, okay, that's a y-intercept, then we could note that, okay, I at least know the slope. I know that the slope is 1/5. I can go ahead and plug that in. Nothing wrong with that. And then I can note that this is an xy pair, 0, 6. So I could let x be 0 and I could let y be 6. Let's substitute those into the equation and solve for y, or excuse me, solve for b. So y is 6 is equal to 1/5 times x, which happens to be 0 here, so that's handy, plus b. So I've got 6 on the left. I'm going to do my multiplication on the right. 0 times anything is 0. Plus b. Okay. And now, regardless of how you think about this, let's see, 0 plus b is b. Or you could subtract 0 from both sides. You get the same result. 6 minus 0 is 6. That will give me 6 is equal to B. So that is an alternative way to find the y-intercept for that particular equation. We already knew the slope. We could just plug in that xy pair to find the y-intercept instead of graphing. Questions on that one? Is that making sense? Yeah, okay, awesome.
Yeah,
Other questions?
I haven't even started the Tuesday lesson, and this is really hard to swallow all of this. I've never worked with these before. I think I'm kind of into the tutoring thing because this is a lot to swallow.
I
It's
think, go ahead, sorry.
Yeah, it's all right. It's not like, I don't know, the terminology, it's just the whole thing.
It does take some getting used to, particularly for stuff like this. The tutoring center can be really helpful because they do linear equations a whole lot. I'm also happy to set up times if you want to work through some of this.
But you've been tutoring down at Penn Valley or?
There's some at every campus. Every MCC campus, there's also some online that you can do.
Okay, because usually if I need tutoring, I go to the math lab at Maple Woods.
Yeah, that works. That works.
But I haven't been there on this class yet.
Okay. This material they should be just fine with. Some of the other material, they're maybe less familiar, but this material they should be totally fine with helping you with.
Yeah. I can't remember what time they close because the only time I can do tutoring is after work.
Okay.
I'm thinking they
I
close
can
at 5.
I can look it up and send you or just send out to everybody some information about tutoring.
I think they close at 5, I think is what the limit is on most days. Maybe Fridays, they
possible.
might be a little bit shorter.
That's possible.
And I don't think there's any tutoring on the weekends.
No, there's no weekend tutoring. But there's also like there is a Zoom option. Like I know Longview has a Zoom option that anyone can use. And so if the issue is transit time, like you could go right out, could just jump online right after work. That could maybe be an option for you. It seems like to me that there is an evening that they're open late as well, but I'll have to look into that to be sure.
Yeah, because both of these are due on Tuesday and we're already on Thursday. I don't even know if that's a possibility tomorrow. You already posted the video from Tuesday's lesson, right?
I did, yes.
Yeah, I'll take a stab at it. I'm
Okay.
not holding my breath that I'm gonna get it the first try, but and then you'll post this one.
I'll post it by tomorrow for sure.
Yeah.
Hopefully before that, but yeah, at least by tomorrow.
Okay. Cause I bet this section gets pretty deep as we keep on going through it. I mean.